the Institute for the Study of Peak States presents the second International Psychoimmunology and Psychobiology Research Symposium. Paradox and Catastrophe as Milestones in Research, presented by Michael St. John.
Okay, and now we are on to our last presenter for today. So Michael St. John first got acquainted with the Institute's work in August of 2004, completed the trauma therapist training in last year, and is working towards certification. While his formal background is in the physical sciences and engineering, he's taking in informally much of the life and psychosocial sciences and has studied the history of science. For the past 4 years, he has offered his services by word of mouth advertising on a pay-for-results basis to those who can afford to pay. So far, he has seen about a 90% success rate since incorporating the certified trauma therapy techniques that he's learned in the training and similar techniques. So, Michael, over to you.
All right, so hello everyone. I'm going to be diving into the slideshow pretty much right away because it's highly compressed. This would normally be about a 3-hour talk here. So I'm going to just dive right in and let me get the screen share set up. Yeah, okay. All right, so paradox and catastrophe as millstones in research. It looks like the gremlins have been added again, but it may be just as well because that is how many people doing research experience paradox and catastrophe. They run away from them as far and as fast as they can, or they do everything they can to dress them up and make them look like they're not actually paradoxes or catastrophes. So let's see here, let me get to my slideshow and not the Zoom. Okay. Come on. All right, so is my slideshow now changing pages for all of you?
Yes.
Okay, good. So paradox and catastrophe as milestones in research and how they arise as system boundary problems. So very, very briefly, when you run into paradox and catastrophe doing research, that should be cause for celebration because you've run into your system boundaries. And that's really, I think, where we want to be doing research. We want to be at that edge, pushing the boundaries. And we'll get to, around the middle of the talk, we'll get to just exactly what are the system boundaries. But what I want to start off with is just some very, very basic stuff. And so with that, what is research? And what is the job of a researcher? And I would say that a researcher has one job. It's a very simple job. It may be difficult, but it is very simple. And that one job is to figure out one damn thing after another. And the reason why they're called damned things is because they're very difficult to deal with. There are two main classes. One is those things that shouldn't exist, but nonetheless do, and they refuse to go away. How rude of them. And very annoying because they have a tendency to just trash our most beautiful and cherished theories. Then the other class is those things that don't exist, but the people you're working for expect you to have created them yesterday, if not sooner. And like you're some sort of magician or a god. And in both cases, it's very difficult to figure these things out. But if you can remember 3 things, this will be like your guide through the whole process. And that is belief is everything, belief is irrelevant, paradox rules. So why is belief everything? Why is belief irrelevant? And what are the possible meanings of paradox rules? So first we'll go into an illustration of why belief is everything. So these are two of my favorite quotes. I like to take them together because together they're very much more powerful than either one by themselves. So as you believe in your heart, so it shall be unto you. Now, at first glance, that just looks like a description of confirmation bias, that we tend to see what we expect to see. But it goes a bit deeper than that because it's talking about what you believe in your heart. And this is what we today would call a core belief. And it's a sort of belief that we don't think about, but instead think from. It's a sort of thing that it just occurs to us as true, sometimes as true with a capital T. Like it wouldn't even occur to us to consider the possibility of questioning it. We can be that certain about it. And then the Einstein quote, when I first found it, I found it in this form. When I went to look it up afterward, I couldn't find it in this form. So it's possible it was a misquote when I found it, but written this way, it's really much more powerful because it focuses on the answer rather than the question. So why is that answer so important? And why is it so important to answer whether the universe is friendly? And that has a lot to do with biology. And so our cell membranes have receptors. They're like antennas that look out into the world to see what's going on. And in a very, very simple sense, we have receptors that look for those things that nurture and support us, and other receptors that look for things that threaten and harm us. And our cells have the capacity to switch, between a mostly nurturing environment and a mostly threatening environment. And what also happens is that the more time a cell spends in one environment, the more adapted it becomes to that environment. But there's a very interesting little thing that happens when you spend a lot of time in one of those environments, which is that for a cell in protection mode in the hostile environment, it can only stay in that mode for a finite period of time because it's not taking in as much in the way of nutrients, it's not getting rid of as much in the way of waste, and it's not doing as much repair work on itself. In contrast, a cell that's in growth mode is living in paradise and it can stay there forever. And the unexpected thing is that if you drop a cell that's fully into growth mode into a hostile environment, it's more adaptable to that environment and can actually make changes to allow itself to better survive that environment such that it can turn that hostile environment into a paradise for itself by changing itself. Now, every living thing is always answering this question of whether its universe is friendly, and it changes its own internal biology in response to that answer. And so this is how belief can be everything. The universe tends to show up the way we expect it to show up from our very deepest level. Now, how is belief irrelevant? So that's illustrated by this little saying. You could ignore reality, but you can't ignore the consequences of ignoring reality. And the best illustrations I found for this are from the Darwin Awards. And here we have one example. Mr. Frankel of Russia believed that he could use psychic power to stop moving vehicles. So he one day decided to test this belief by standing in front of an oncoming train. It didn't stop. So yes, belief is irrelevant on some occasions. And so when you understand how each of these things operates, how belief is everything in some circumstances and how belief is irrelevant in other circumstances, these become the rules of paradox. And you can navigate paradox and catastrophe with confidence, not necessarily ease, but with confidence. But if you don't understand how these things operate, then paradox rules over you. Now, framing paradox and catastrophe as system boundary problems relates to how it is when we engage in research and many other areas of endeavor, we have to set system boundaries in terms of what is relevant, what is possible, what is likely, and what is important. There are many, many other considerations for system boundaries, but these are the minimum key parameters. And they're set because we have limited internal and external resources to engage in the activity. So we don't want to waste time and energy on the irrelevant, the impossible, the unlikely, and the unimportant. However, we can be wrong about any of these, and sometimes we can be wrong about all of them, sometimes dramatically wrong. And so when you run into a situation where you're encountering the things that shouldn't exist but just won't go away, that's a really good clue that you've run into your system boundaries and need to re-examine what's relevant, possible, likely, and important. And related to that is the metaphor of laws in science. And it would be far better to speak of them as articulated principles, because that reminds us that we created the articulation. When we use the term law, we often conceptually go into the realm of thinking that these things exist separately and apart from us. And while the universe has its operations that occur regardless of our beliefs about them, our articulations about those operations can be missing. They can be, incomplete. Sometimes they can be just flat out wrong. And so when we get into that concept of laws, we go into cognitive closure. And this is where settled science, tries to tell people, pay no attention to those silly old men behind the black curtain. So there's a saying that's come up that if it's science, it isn't settled. And if it's settled, it isn't science. And this has to do with that whole thing about cognitive closure, because in research, cognitive closure, being absolutely certain about something, is a death knell to progress. And so within this, there are two primary causes of paradox, and their resolutions are relatively straightforward, not easy very often, but straightforward. So one of those is where we're absolutely certain about something that just isn't so. So that has to do with how belief is everything and belief is irrelevant crash into each other. So we can be absolutely certain about something and it just isn't so, and the universe is just going to go on and do its thing anyway. And then the other thing is what we don't know that we don't know. It's the double unknown. And getting around that is harder. And the first one, you know what you're up against when the things just won't go away. So you start questioning everything you assume must be true, even if it's difficult to question it. When it's something you don't know that you don't know, sometimes you have to do things to loosen up your thinking. You have to, talk to people outside your field, start looking at things outside your field, just anything that will expand your way of thinking about the problem, sometimes by just not thinking about the problem and looking at something else and letting your subconscious do the work in the background. And talking to people outside your realm of endeavor and just explaining things in a non-technical way and gathering thoughts and perspectives, because something might come out that way. It's a blind spot. So the only way you can explore the blind spot is to start turning around and asking for other people often for their insights. Now, here we go into a real life example, and I'm going to be mindful of time here. So the paleobiogeography of the Pacific Basin calls for a closure of that basin at the time of Pangea. That's some 200 million years ago, approximately. With standard plate tectonics, that is a categoric impossibility, because the Atlantic Basin has to be closed at the very same time, and there's no way within the parameters of modern plate tectonics to accomplish that. So it is a paradox and a catastrophe at the same time. And this is actually a pretty serious idea. We've got, just for one example, a professional, what this would be called a scholarly article on the topic. If you want to buy this PDF for yourself, it will cost you $60. It's that kind of a scholarly article. And in an attempt to solve this, back in 2001, James Maxlow published he did his doctoral thesis, he got his doctorate, and it's on the possibility of the globe of the Earth changing its diameter over time, that it was smaller in the past and is going to be larger in the future. He did his master's thesis on essentially the same topic, just closing the ocean basins of the world. The doctoral thesis explored that further by looking at the continental land masses and applying the same methodology. And this was across many different data sets. So mineral deposits, ancient life, ancient seabeds, magnetic poles, and more. Back in 2000, it was already clear to some people that the plate tectonics paradigm was under threat. But the idea of this goes back very far. At least 1888, in Russia, there was the first publication. Samuel Warren Carey, who was one of James Maxwell's professors, attempted to insert that into his 1938 doctoral thesis, but removed it at the last minute because he realized it would cost him his doctorate. It was a very hostile environment for that kind of idea at the time because, well, it was really threatening because it threatened the foundations of a lot of sciences. So to accommodate an expanding Earth, we have to not only rebuild geology and geophysics from the bottom up, we have to look at physics, cosmology, and astrophysics, and several other disciplines such as paleoclimatology and paleontology. It's the mother of all catastrophes. It's more than a mega catastrophe, more than a giga catastrophe. I would call it a terra catastrophe, all puns intended. And so to give you a quick view, this is the Atlantic Basin. You'll notice that the color bands are all pretty uniform. It's a very gradual expansion of the Atlantic Basin. But when you look at the Pacific Basin in contrast, it's very different. So what I want to do is draw attention to this little orange-red band here. This is a span of 30 million years. It covers about 10 degrees of longitude here. Okay, when we go to the Pacific Basin, it's vastly different. This same 30 million years covers 45 degrees of longitude. Okay, and the distance covered in the Atlantic, that 30 million years, that's maybe a bit less than 1,000 miles. In the Pacific, it's 80% of the width of the Atlantic Basin. It's like 3,000 some miles. It's huge. And so it takes looking at the age of the ocean floor and systematically stripping away age by age to figure out how the Pacific Basin might knit up. And that's what James Maxwell did. Now, I've got to move quickly, so we're going to grab a few nuggets from a publication known as The Programmer's Stone. And so there are two big takeaways from there, and these relate to cognitive processing, things he labels packing and mapping. And these are how people organize their learning and problem solving. Packing can be thought of as rote memorization. And you just pack in as many disparate elements as you can. You don't take the time to interrelate them. Whereas mapping still involves memorization, but it involves connecting as many dots as possible to as many other dots as possible. So it's a very richly interconnected and interwoven picture of the world. And this really comes into play in problem solving, because when the packing style is applied to problem solving and you encounter something totally new, the thing comes to a crashing halt. And people cast about with ad hoc solutions, sometimes totally random solutions. And when something sort of works, they cling to it and sometimes enshrine it because it's so hard and so rare to come up with a solution in such situations. But with the mapping strategy, what happens is people just extend their known map out, look at the results of doing that, and make changes and iterate on that process. They just repeat it until they get something that fits well enough. And then later, if they have time and interest, they can go back and refine it more, and they can do it efficiently because they've built understanding. Whereas with the packing strategy, you generally don't build understanding. And the relevance of this to evolutionary theory and immunology is pretty profound, because with the work of Barbara McClintock in 1932, and she discovered just what we now call transposable genetic elements. John Cairns with his study on bacteria showing adaptive mutation, and James Shapiro back in 2002 when he did a study with I've forgotten the type of worm, but they reproduced sexually, and he could show that they made adaptive changes that propagated through the germline. You can't explain this using standard Darwinian theory because it's based on a packing style of evolutionary change where it's fundamentally random. And with the emerging theory of evolution, it relies more on a mapping style of evolutionary change, and it can robustly explain the emerging and mounting evidence in support of adaptive mutation. So I'm going to take a few quick examples from ISPS research. And one of the key things that I learned from talking to Grant about this is that he himself was not bogged down by the usual internal stuff that keeps people from taking a candid look at failure. And so he experienced disappointment, sometimes crushing disappointment from failure, but he didn't take it personally in the sense that he didn't have his identity tied to the work. And so in the discovery of the primary cell, it was totally accidental. It came out of a sweat lodge experience when Grant found himself in this unusual state where he was seeing things in his environment and being able to see things in other people. And it took quite some time, years, if I remember right, before he and others realized that they were seeing inside the primary cell. And it took them a while longer to figure out just what it was they were seeing, how to identify the specific things. And then after that, it took a while longer to figure out what to do with them. There were things inside there that were assumed to be native parts of the primary cell, but it turned out that they were cellular parasites. And that's a whole story that I'm not going to get into right now, but it was quite a shock when they discovered that, oh, these are parasites, and some people's primary cells are virtually filled with them and others are relatively clear. And then with the column of self, that was a structure that was discovered early on while exploring dissociative identity disorder, also known as multiple personality. And so it was known as a structure inside the cell, but it was quite some time after the discovery of the primary cell parasites that it was discovered that it was also a parasite because it was atypical in its appearance. And so once they started discovering atypical parasites, eventually they were able to figure out that it's a fungal structure. And this is how it appears to some people who can visualize it within themselves subjectively. The things inside there are defects in the column that produce symptoms in the people who have those particular defects. The bubbles can cause distractibility. The larger voids can cause compulsion to identify, to set one's identity with someone or something outside oneself, because to have one's identity within oneself just feels really horrible and awful. And so Grant and the others were able to make these discoveries because they were fortunate to not have the things that hamper other researchers in doing this kind of research. When they run into paradox and catastrophe, they can usually face it head on. It can be very difficult, but it's very straightforward. And so this is how, belief is everything, belief is irrelevant, paradox rules. And remember to say your prayers to St. Murphy, who was the patron saint of everything that could possibly go wrong. And so with that, this is my contact info, and I will end the screen share and see if I have time for questions. Let's see, where do I do that? Stop sharing. All right, so I might have a little time for questions if there are.
You do have time, but at the moment we don't have questions.
Oh,
so
okay.
Great work in getting us back on track.
Yes, and I struggled for weeks to get this thing down, and I didn't think I could do it, but I did.
No, you did
Awesome.
well. You did very well.
Thank you for watching. For more information, visit pigstates.com.